Hello, my name is Jonathan Bisnet, and this is the fifth in a series of videos on BJT transistor logic gates. And in this video, we're going to focus on the NOR gate. So we're actually talking about this set of transistors right here. And in fact, let me turn this a little bit just to give you a better view of this. We're talking about these transistors here, just below the red line there. So the way this works is, you'll see here, we have two transistors here on the left. Both of them have a connection between ground and the emitter. They both have a 10K ohm resistor between the base and ground, and they both have, well, they have a connection between their collectors. You'll see this one brown wire here going from one collector to the other, and then another wire going off the second transistor to a third one, which I'll explain in a minute. They also have, each of them have a 220 ohm resistor off the base that then goes to this yellow wire and ultimately to ground. Those are the two inputs for our NOR circuit. The 10K ohm resistors are used to basically put a ground potential on the base in the event that there is either no input or the input is grounded. Therefore, the transistors will be in an off state until they receive a positive voltage on the base. So in their current situation, they're both off and neither of them is conducting. If we then look at the wire off this second transistor going over to the third transistor, in this case the third transistor is basically identical to a circuit I showed you previously, the NOT circuit, and it really, the input is coming in going through this 220 ohm resistor to the base of this transistor, which also has a 10K ohm resistor in it, although you'll note this particular one is connected to positive potential. In essence, keeping this transistor in an on state unless it gets that ground condition on its base input. And then it has a connection to the emitter, from the emitter to ground, and then you'll see another brown wire coming off the collector and going into a fourth transistor. This final transistor is one I've talked about in several previous videos. I'm calling it a staging or an interface transistor, and its sole purpose, it happens to be a PNP transistor. Its purpose is to invert the negative logic that the NPN transistors are providing. So a ground signal coming off this last transistor in a negative logic scenario is the same as, in essence, saying it's on. What the PNP transistor does is convert that or invert that negative or that ground signal to a positive 5 volt signal, so that 5 volts is considered to be a 1 rather than a ground condition. And it's configured in such a fashion. You'll see that the emitter is connected to the positive rail. There's a resistor going from the base to plus 5 volts or the positive rail, in essence to keep that transistor in an off state unless it receives a ground signal on its input here through the 220 ohm resistor. And then finally you'll see the wire coming off the collector and going to the LED, and from the LED to ground through the resistor. That in essence is our circuit here. Now if I pull back out just a little bit, we can mess with the, I'm going to change hands here and we'll mess with the wires here a little bit. If we take this one, you'll notice the light is on right now because currently we're sending zeros into our circuit. So if I take this one out and move it to positive, note our LED went out, because at this point we have our initial two transistors, which operate like an OR, you are getting a 1 into one of them, which means a 1 is going out into the NOT portion of the circuit, which should be outputting a 0, and our interface transistor is converting that to true ground condition. The same will be true here. If I move this guy to positive voltage, still nothing. I move this guy back to ground, nothing. Move this guy back to ground. Notice we get it as soon as I pull him out. The light comes on. So in the event that we're sending in 0, 0 to our OR gate, it would output a 0 to the NOT portion of the gate, in essence the rest of the NOR, and that 0 becomes a 1, and the interface transistor turns it into a positive 5 volts. That's how this particular circuit works. I'm going to go ahead now and look at the schematic here. And again, you'll see on the left-hand side, we've got the equivalent of what we had in our OR circuit with the emitters on both the transistors Q2 and Q3 connected to ground. We have two 10K ohm resistors connected to ground that attached to the base to keep those transistors turned off until there is a positive potential. You'll see the two switches, J2 and J3, which provide that positive potential through 220 ohm resistors. So when the other, or both of them are on, those transistors will go on, in which case Q2 and Q3 will output a ground potential through the 220 ohm R8 resistor to transistor Q4, to its base. At that point, that will turn off Q4, and it will, in essence, float the 220 ohm resistor. There will be no potential going through it. Instead, Q1 will see the positive potential off of through the 10K ohm resistor, in which case Q1 will be off, and you'll see the LED will be off. If both of the switches are open, then both if both of the switches are open like they are now, then the two transistors Q2 and Q3 will be off, as we said, in which case no ground potential is provided, and instead Q4 sees the positive potential through the 10K ohm resistor R9. That causes it to be on, and it provides a ground potential to the base of Q1 through R2. And at this point, Q1 then, being a PNP transistor, seeing that ground potential, turns on, and LED 1 goes on, and your circuit in essence ends up coming off the positive supply through Q1, through the LED 1, lighting it, through the 220 ohm R3 and back to ground. That is, in essence, how this circuit works. You'll see at the bottom we have our truth table. Again, it looks like the opposite of an OR gate. The only time the output is on is when both the inputs are off. Otherwise, the output is off. So, that is a NOR gate done with a series of 4 BJT transistors. Hopefully you found this interesting, and you'll take a look at the other videos related to logic gates. Thank you.